Yeah, good job, mount. Thanks, Bob. I'm going to pat the mount after. If I pat it too strong, it'll land up in the St. Lawrence Seaway. Okay, now it's, I think I got it finally. Oh, man. You know how long, Tim, I've been working on that mount to make it work right? Gee whiz, it's the first time. Okay, this is M92, and it's located much higher, obviously, and you can see the image is much brighter. And we're still at 1 second compared to M3, which was way too low for us. We had to go through a lot more air. And M92 is higher. Here's one, oh, sorry, it's 2 seconds. Oh, okay, let's bring this down to 1 second exposure. And because of that, there you go, here's 1 second, and the center is actually a little bit overexposed. And I might be out of focus a little bit, but what I'm going to do is this. You could choose region of interest or change. Ah, that's what I want to see. It doesn't look good though, doesn't it? Well, this is what we want. We don't want this image to look good right now because I'm using 400% magnification. Here it is here. And why am I doing this, folks? Watch this. Hopefully you're going to be able to hear me because I'm going to use that mode to focus. I want to get the best star possible. And for that, I'm going to go down to half a second. How is that? 500 milliseconds. Let's go half a second. I want to reduce the star density. This is half a second, folks. Just look how sensitive a real video camera, not an imager, huge difference. And why we choose to go with an interlaced sensor. You have the proof right here. Half a second exposure, folks. Why do I want to get at this? And here's the other advantages. You actually see color in the stars. Now I've got the image set at 400% compared to 100%. Here's 100%. On the software, on the fly, you could change that. I want to go 400. I want the ugliest stars as possible, and here's why. It will allow me to make an ugly star turn a little bit better. And what I mean a little bit better, by adjusting the focus. I'm going to get up. I'm going to unlock my mount. Hopefully these guys can still hear me from where I'll be standing. All right, there we go. Watch this. Let's turn the focus a little bit. Is this going to go more fuzzy? Oh yeah, look at that. See, you touch up the focus a little bit and it won't take long. You're going to get one ugly star formation. So let's keep turning the focuser slowly. As refresher going, you could actually see the guider do the correction. Look at it. Look at the image moving all over. When we magnify the image, that's what happens. If you use a F ratio too high on a scope, that's what happens. Your image is going to get blurry because the guiding cannot do it quite bang on. And the less magnification you have, the more forgiving on the tracking. Look at that swing all over the place. Wow. Pretty amazing. Let's go back into focus. And the advantages of using a zoom or anything like that is allow us to, let's turn those stars into the best as we can. We're not looking to get the best stars, but the tightest as possible. Although they are ugly. Hang on a sec. Okay, I gotta get up. I gotta get up and come back to the scope and look at the screen and try to pinpoint the exact spot where it's going to be usable for us. Once we got that focused, determined for what window, no, it's fuzzier here. All right, hang on. Once we got that focus going, we'll be able to zoom out and watch what's going to happen to the image. Of course, we'll never observe with such magnification like that. It's not the point, but the point of having it at 400% bigger is to get the best star pattern we can. There we go. Well, so far it's pretty hard to beat what we got now. I think it's the closest we'll ever get. I'm going to lock the focus. It's pretty well close to what we're going to get for now. For the sky conditions. So let's go on top. Take that 400% magnification, go back to, see the stars, how much pinpoint they are? Focus is critical, folks. And look at half a second exposure. The amount of detail we're getting in there, half a second. That's plenty for you to focus, center your image, and make any adjustment you need to do. Again, we've got the gamma set at 60. Half a second, let's put the gamma at default. We're going to lose that object. Gamma also changed the gain of everything, of the image. So let's go back here. All right, 57, that's close enough. We just need rough adjustments. And histogram, same thing. Where's the histogram set at? 122? Okay. If we go default, let's see what's going to happen. All right. I tell you what, let's go to gamma and default. Boom, it's gone. I mean, you just see a little blurb. So's the stars everywhere. Interlaced chip, that's what you can do with them. That's why Mallin can choose interlaced sensors. Now, let's go back and reinstate what we had. Maybe 100 be too high. Actually, no. 100 is good. This is a half a second exposure, folks. Half a second. And the gamma, we could probably lower the gamma a little bit more. 045 is a spot that I like because it's usable. Look at that. This is M92. M92, folks, at half a second. 500 millisecond. You don't believe me? Here it is. Here's seconds, milliseconds, and microseconds. Camera could go to an hour, but you'll never use that, ever. This is an 8-inch telescope, by the way, not the 16-inch I usually use. That's not all. Look at the gain here. The gain is set at 3.40, so you can bring that slider up. Let's crank it up and see. Now we're starting to get noise. Don't forget, we're dealing at half a second. And what you need to do is lower the gain until that noise is gone. Personally, between 2 to 3 point, well, here, you could actually click on the, 3.40, I find is a really good setting for smaller to medium-sized scopes. We're still half a second, guys. Look at this. Now, with that, you get to focus on real time just about. You get to center your image real time. If you have a Dob and you're using this on the Dobsonian, you don't have good tracking, it's still usable. That's my point. Keep the exposure short and do the other adjustments. Only stick to gamma and histogram. Don't touch anything else. So Alistair, it says right on top, Mallin Sky. Go on the website. There was a website that can, go read on the website there, Alistair. It's all on the website under the SkyRaider. Okay, let's go back here, folks. Half a second exposure, and look at the colors that we're having in the stars. I have to repeat this. It says half a second. There's not one camera on the market that has that sensitivity if it's properly adjusted. And if you've got a mount that don't track too well, you are safe. You get to use much lower exposure and do the other adjustments to get what you need without noise. And here's the proof. At half a second like this, 500 milliseconds. Look at the amount of noise that we have. It's next to none, unless if you crank up the gain, which is boosting the preamplifiers and everything else in the circuit of the camera, you're going to create noise. You don't want to create noise. All right. Is there any questions so far to this point? Okay, we're going to carry on unless somebody's typing. That's good. So again, we're half a second, folks. Okay, hang on. We'll support the direct broadcast. I'm not sure. Rees in Wisconsin, not sure yet, but I'm hoping that they will do it. The engineers are working on it now. Okay, Alistair, let me show you why. I think you missed what I said earlier, Alistair, but I'm going to answer your question. Let's go back. Jim, this is M92 now. We've changed object. Let's go back to, when you see lines, Alistair, that's because you are taking an image of odd feel and even feel. Here, let's boost that up. If the mount moves or the wind blows or the camera moves, you're going to have a line difference. Those lines is the odd feel and even feel, because when you take an exposure, for example, at 500 milliseconds, like we're having it now, okay, what's going to happen is you're taking a 250 millisecond exposure of odd field, and you take another 250 millisecond at even field, and once both are taken, it's assembled together to form an image. If the mount moves or the wind blows on your tube or anything like that, you're going to see some minor lines because the interlace are not lined up. The odd and even feel are not lined up, or you're getting only an odd feel view or an even feel view. That's the reason of the lines. See? We got lines now. Whoop, what's even worse now, because the tracking on the mount is all that good. This is 400 times magnified. And if you back up, you won't get that effect. You won't be able to see that effect as much. Yeah, progressive would blur the whole thing completely, exactly. That's because progressive reads in one shot. But progressive is very limited what you could do, Alistair. And the reason is this: I'm going to use a dark field correction after, right here, and I'm going to show you why we're going interlaced with odd and even feel. I'm going to show you. I'm getting there. Don't get ahead of me, Alistair. Okay, Mitch, sounds good. Thank you very much. It looks like I'm going to be late. Yeah, Mitch, you should bring your machine gun, your gun, so I could watch for those wolves, because last time they were right behind the dome here, near me. But anyways, that's no big deal. I don't need it. I'll deal with it. Okay, sounds good. I'll just watch for the holes too, near the back of the house. Thank you. Okay, let's go back on the program, folks. We're going to do one step at a time here. We're going to continue going. This is a half a second exposure. Here we go again. Reason it's half a second is it's taking 250 millisecond at odd field, 250 millisecond at even field. Therefore, it'll take 1 second to see the image because it needs to assemble it. Odd field, you're getting half of the information. Even field, you're getting half the information. By splitting those, like we're doing here with that type of chip and the SkyRaider that I designed into the software and mainly to the electronics, is this: we get to use a dark field correction. Now, what is that? I'm going to show you. Watch this, folks. Here it is. Basically, what it's going to do is take an odd field dark frame and an even field dark frame. You will be able to remove everything. When I mean by everything, it goes far beyond a simple dark frame. That's why it's called a dark field correction. By splitting the odd and even field, what we're doing is we're taking every pieces of noise that there is in there, including warm pixel, hot pixel, even dark current noise. And we are taking a picture of that, take it out, and then when you go into the even field, it also takes an even field of the same. And when it's time to subtract it live, you don't need a Peltier cooler. There's not one technology that's been developed that way. We are the first in the world to ever come out with this system. For 3 years we've been working on this camera. Here's what I'm going to do. We're going to set gamma back to gamma default. We're going to go with default on the histogram. Now, we were half a second exposure, if you remember. And of course, we see next to nothing. How about, now in this object, we're going to go I don't know, folks. Let's choose 5 seconds. And yeah, 5 seconds even. Now everything's at default. Okay? Let's wait for the 5 second, and there you go. See the lines in the center? I switched to the mode between the odd or even field reading. Watch the next refresh. See those lines? There you go. The even field just got applied. That's what those lines are. You got to wait for the odd and even field to be combined. And if they are, then the line goes away. Oh yes, Alistair. I took advantage of this design right down to the core. Okay, 5 seconds not enough. I want to go more than that. How about 8 seconds? It's going to give us the gain we need. But also I want to work with the gamma and histogram also. Remember, I want to keep the shortest possible exposure that I can get. Here we go again. I think we got lines in there because I switched before we got the other refresh. Watch this. This is odd field. Even field's going to come up on the next refresh. Watch. See the lines in the center core? Boom. There you go. They're gone. That means the odd and even field got combined together to show you the final image. Now because the core is overexposed at 8 seconds, let's verify that. Yeah, we're not going to bother with the microseconds. We're talking about microseconds. But if somebody wants to get anal about it, here, we'll put it 0 exactly. There you go. 8,000 milliseconds, so 8 seconds dead on. Now that's going to make a difference. Okay, let's go back to the gamma. Now, of course, we're not going to use the same setting on the gamma. Don't go as aggressive. We were down to 15, 60. Let's try 70, 73. And for that, we got to wait about 16 seconds before the image comes up. Oh yeah, it does. Watch this, Alistair. All right. Let's lower the gamma a little bit more. About 6. There you go. Now we're starting to see more stars in the field around M92. And look at this. We're still picking up colors. Now we've got lines there. I did the changes before we had a full refresh. There you go. Okay, now we got it. Let's go to the histogram. And we do have our pixels in there. Don't worry. This is not perfect yet. It will be perfect in a few moments. Okay, we'll go about 150 on the histogram because we're dealing with an 8 second exposure. That's quite a lot. Let's wait for the next refresh and see what's going to happen. There you go. All right. Wow, we're picking up faint stars in the background. That's cool. And here we got information. If you click on frame rate at the bottom of the screen, we've taken 1,387 frames, and time in seconds so far that we've been imaging is 3,000. There you go. Here's your video height, 576, 748. Still image captures. Nah, I didn't take one yet. Serial number and what model it is and the value. Okay, watch this now. You want to take a picture of what we're looking at? You see on the left here, it says snap. Here's the, too bad you can't see my mouse, but if you look on the left, here's the tab for the exposure, and right above you've got snap, you've got live, and you've got a square button that says snap. Hit that once, boom, here's your image right there. This is an actual image, folks. You go with the mouse on top, switch the tab above the image. Here, this is live. When you click on video, and SkyRaider 440 DSc is in bracket, and the number beside it, 001, that's the image you just took. There you go, switch it over on the image. Now this is the image. With that, now we're going to go and process that image if you want. You could sharpen it, unsharp, and do all kinds of stuff. But this is not live, so we're going to go back to live here. So click left on the left click on the mouse on the video SkyRaider tab. There you go. Now that's live. And how can we prove this? Easy. Let's go to the picture. That's the picture we took. And you can tell the difference from the tracking now. Look at this. This is live, and that's the picture we took. Live. The picture we took. Live and picture we took. And for that, to prove you even more, let's go with the zoom on the image. This is the image we took. It's fixed. It's there. That's it. And this is live. Image we took. Live. Image we took. Let's put it back to 100%. There you go. I want to save that image. Well, there's two ways to do it. You could go in the file on top, save as, or you could do a batch save, so you could have a bunch of automatic snapping away of pictures while you're viewing live. Or one way I like to do is I right click on the number 001. No, small mistake. Sorry guys. Save as. There you go. Let's save this. I don't know. There. No. This is my new computer, so I'm not used to it. It's Windows 8.1. There you go. That's what I'm looking for. All right. SkyRaiders. Boom. All right. What do you want? This Windows bitmap? Yeah. You want JPEG? I mean, there's a whole bunch of format you could go. I'm going to go JPEG. I like JPEG. And we're going to call it M92 underscore A. All right. Save it. Boom. Done and saved. Now it is renamed on top. M92A.jpg. This is live. This is the image. This is live, and this is the image. Okay, now we're going to close that image. Just that image only. Okay, we're back to live. Any questions so far? No, there's no such thing using a USB camera. When you use a USB camera, you no longer go with NTSC or PAL. It basically reads the odds and even field only of the chip with a USB camera. If you go a true video like the Extreme Exterminator, then yes, because the output's got to be tuned through your monitor, not your computer. So this is a PAL sensor. It is an i6-829, but the pixel's a little bit more square than the NTSC model, but you don't have an NTSC here happening or a PAL. Basically what the software does, it reads your odd and even fields as required because it's full digital going directly to USB. So there's no PAL or NTSC to worry about. Okay, so now again we are back to, let's go back on the subject here. Another question? Oh, Lance, good. Okay, glad to see that, Lance. Right on, good. Well, Alistair, you know what they say. Cameras don't lie. They pick up what you feed them. Now, we're going overexposed here, obviously. So the colors were real. What we see for color, that's what it is. I know when I'm in the daytime and I look at the sky, I know it's blue because it is blue, because I see it. Sensors seeing the stars the same way. There's no such thing as, if it's a white star or a blue star that shows up yellow or red, it doesn't make sense. It's going to go through the matrix and pick up the color that's being radiated from. Okay, we're going to lower the value here. Let's go back to subject. We're going to lower the values. What I want to do is this, actually. That's what I wanted to do. You got me sidetracked again there, Alistair. Oh yeah, if the stars are yellow or blue or red, Alistair, that's how they show up. Here's what I want to do, folks. We are going to make the image look ugly, all right? Now, the exposure is 8,000 milliseconds, which is 8 seconds. And the gain is up, and the mosquitoes are coming back out again. Okay, Jack is recording everything, Tim, by the way, so it's going to be really easy to review. But, Stick to the three things, all right? Three things only with the SkyRaider. I know a lot of people like to play with everything, but do you want good result? If you do, first of all, exposure in your game. Set that up to the lowest level possible. Color adjust. Only play with the gamma. Look, the contrast at 0, brightness 0, saturation is 128, hue is the same thing. Don't touch it. Now, histogram is the same thing. Yeah, I'm going to lower the histogram actually some more. And the reason I want to do this, actually, let's go default here for a minute. Let's see on the next refresh what we're going to see. Wow, that's not bad at all, actually. But here's the part I want to come to the point here. Let's make the image look a little bit uglier. This is 8-second exposure, folks. All right. Let's lower that a little bit more. 150, maybe about 172. All right, let's wait for the next refresh. Don't forget, we have to take an image of 8 seconds odd and 8 second even field. So you'll get the image in 16 seconds. I'm going to lower that a little bit more, actually. Hang on. It's on the website, Sam. If you go look on the website, $699.99. Okay, folks, watch this. We are going to take a dark field correction, and for that, you know what I'm going to do? I'm going to increase the exposure a little bit more. I'm going to step up to 10 seconds. I know we're going to have it overexposed on the core, but I also want to bring noise in there. Although it's very hard to do, obviously. See how clean this sensor is. And this is the color version of it here. The software comes with a camera, and not only that, the USB cable supplied with all other cameras on the market only comes with a 1.8 meter. You're talking like 2 feet long, 3 feet long. We supply a premium grade 15 feet 5 meter cable. You shop around and see how much these cost. We supply that with a camera. So you don't have to buy another cable longer to reach your telescope. It comes with the camera. Okay. We've got 10-second exposure, folks, and one of the reasons I want to bring some of the artifacts as much as we can, we've got the gamma set fairly high, actually. We might lower that a little bit. That's quite a lot here. Let's go to 70. Gamma 70 should be all right. Let's wait for the next refresh and watch what's going to happen here. There you go. Here's our refresh that just happened. What are we going to do is I'm going to make the histogram lowered because I want to make the image look ugly and bring artifacts. Okay, 66, good enough. Let's wait for the next refresh, and we are going to venture into the dark field. I hate when they supply you with a 2-3 foot cord. Every Mallin Cam USB camera, this is the SkyRaider, Mallin Cam Universe, SSI, or any of them that has, even the guider comes with a 15-foot cable. I made sure of that. I know how frustrating it is for me to go buy another camera and it comes with a crappy little 2-foot, 3-foot cord that you got to be right under your mount, you know, to use in the field. It's ridiculous. And of course, company says, "Oh no, you can't use 15 feet on a camera." Yes, you can if it's designed properly. If the camera has amplifiers to boot, the single built-in, you've got nothing to worry about. If you still have issues, there's an issue with your computer, like I find out last week when I bought this computer. Alistair, I just explained that to you. Jack, might be a good idea for you to pause the video, but I'm going to answer the question. What did I say earlier, Alistair?